Hello, everyone.
All right. Thanks for having me, and thanks everybody for coming to my talk. Um, I saw on Twitter just before this that Matteo Colina is officially sorry he couldn't make it, so I wanted to pass that along to everyone. So my talk is about getting started with Node.js and gRPC. Just show of hands, how many people here have heard of gRPC before? Okay. Leave your hand up if you've used it before. Okay, cool. So a little bit about how I ended up talking about gRPC. Um, I've been working with Node for a long time now, probably since I think 2011, and I'd used gRPC once for like a job interview exercise, but I didn't really like it. And then in the summer of 2018, I had to start on a new project at work that was going to require the team that I was on to communicate with a bunch of Go services that were our upstream, and they were communicating with gRPC. So at first I was a little bummed. I already, I was a Happy core team member. I kind of liked using Happy, but I was like, all right, well, let's give this a shot. But we were running into a lot of issues using the existing gRPC modules, um, and kind of that was compounded by the fact that the upstream we were trying to talk to was unstable and largely unavailable. Um, and no fault of their own, they were developing these things at the same time we were. So things like that happen. It wasn't really an option for us to run the Go services locally. It was a very overly complicated setup. So it turned out that we needed a gRPC client to talk to their services and also a gRPC server to kind of mock out and use for testing purposes. So this is kind of what one of our use cases looked like. It was very simple, having a browser talk to Happy server and Node, and then using gRPC to talk from that server up to Golang services. But we also had other use cases where we needed to reuse the client more than like in multiple locations. So that kind of put another restriction on how we could go about approaching the problem. So first, a little introduction to gRPC. It touts itself as a high-performance, open-source, universal RPC framework. So RPC stands for Remote Procedure Call. The universal part, it's supported by a bunch of languages. So Go, Node, I think PHP, Java, a whole bunch of them. For the most part, they all use a common C library as their core. I think the Go and Java ones are the only ones that don't. And so this was a framework that was developed at Google. They put it into the Cloud Native Computing Foundation. They have the framework has a lot of really large users. Obviously, Google, Netflix, Dropbox, etc. And the high performance part of it comes from its use of HTTP2 and protocol buffers. So you actually cannot use gRPC over HTTP1. So that actually adds some restrictions to things you can do, and I'll talk about that a little bit at the end. Some of the features that it has: 4 different types of remote procedure calls. So they are called Unary, which is kind of what you think of as a normal request. You send one request, you get one response back. Then they also have client streaming, which is where the client sends a stream of messages to the server, and the server responds with a single message. Server-side streaming, which is the opposite of that, where the client sends one message and the server can send back, multiple messages. And then bidirectional, or you often see it called Bidi, B-I-D-I, bidirectional streaming, where both sides are just streaming back and forth. So it's a really powerful way to do RPCs. Another feature is metadata. This generally just maps to the HTTP2 headers. They also support authentication. So you can do authentication with SSL and TLS, and then of course you can use Google Auth. So deadlines and cancellation are another feature. It's kind of, deadlines are basically a timeout. So by default, anytime you submit a request to the server, it will stay open indefinitely. So you best practice is you always want to kind of define a timeout for the deadline so that you don't continue to use server resources unnecessarily. And then cancellation is at any time either side of the connection is able to kill it. It also supports compression, so there's a couple different ones that are supported, gzip, and all the ones that are supported by Node's zlib library. They have client-side load balancing, so that makes it really easy to have a fleet of servers and have your client intelligently load balance between them pretty much automatically. And then they one of my favorites is they have automatically generated boilerplate. So this is automatically generating docs, automatically generating clients, so you don't have to write as much of the same code over and over again. And then instead of communicating over JSON or GraphQL or any of the more typical mediums, they use something called protocol buffers, or protobufs for short. And this is an example of what a protocol buffer looks like. So at the very top, we say syntax equals proto3. Protocol buffers are versions, so this tells you what version of the syntax you're going to be using. The two green lines are just comments. Then where we see message, echo message. So what we're going to do here is define an echo service, so it'll be able to support all four types of the RPC requests, and basically whatever you send, the server is going to send right back. And so the way this message is going to look, it's going to be an object with one field called value, and value is going to be a string. The value equals 1 has to do with the way the protocol buffer is laid out. So all your fields will have different numbers. And then it's actually very useful because there's documentation online about how to version your protocol buffers. So you never want to assign the same, like if you're making changes to your protocol buffer definitions, you never want to change fields and then reassign them to the same number, because that would basically be a hard-breaking change for your client. So it's a really nice way to kind of version your APIs. And then down below is where we actually define our service. So this is going to be all the different RPCs that the system will support. Echo Unary, Echo Client Stream, Echo Server Stream, and Echo Bidi Stream. All four of these are going to take echo messages as input. And then you'll see for the client stream and the Bidi stream that you'll see basically this stream keyword right here. What this is saying is that you're going to have an incoming stream of messages, and then similarly for the server side streaming, you're going to return a stream of the messages. And so there's more to the syntax than that, but it's actually really pretty simple, and just based off of this, you can get a lot done. So the next thing is how to use gRPC with JavaScript. And the bad news is there's not a universal JavaScript approach. There's nothing that you can run in the browser and in Node.js. The browser actually has some fundamental limitations in what it can do with HTTP2. So older browsers might not support it at all if you're still running IE6. And then even in the newest browsers, there's no APIs that give you the low-level precise control over HTTP2 that you need to be able to generate the gRPC messages. And then Node.js is more of your typical backend, target language like Java, Go, etc. And so that's where the HTTP2 comes in. And then for the browser, there's something called grpc-web. grpc-web is kind of another protocol that introduces an Envoy proxy into your architecture. So you communicate over AJAX requests to this proxy. The proxy translates from HTTP1 to HTTP2, sends the request upstream to the normal gRPC servers. And so this is kind of just a diagram of what it would normally look like. So in your REST application, you're going to have your JavaScript web app talking over HTTP2 to your REST API server, and then your REST API server could then proxy those things to gRPC. Once you introduce grpc-web into it, you have grpc-web talking over protocol buffers still via AJAX to your Envoy proxy, which is then going to send the requests upstream. So I guess the most typical way to get started with gRPC is via npm installing the gRPC module. It has functionality to develop both clients and servers, so it's kind of an all-in-one package for all your needs. It uses that shared C core that I talked about a little bit earlier. So what that kind of translates into for Node developers is a compiled add-on. Does anybody in here regularly use compiled add-ons? Do you like them? Not many people do. And so one of the things that's kind of unfortunate about these compiled add-ons is that while they are good for exposing existing native libraries up to JavaScript, they actually, on npm install, they compile the C code locally so that you can run it. Or alternatively, you can provide pre-builds that users can download, and then you kind of have to provide pre-builds based on like Node versions, based on operating systems and things like that. So the gRPC team actually provides over 100 of those. And then they built this thing a few years ago using NAN, which stands for Native Abstractions for Node. It's a nice way to kind of paper over the inconsistencies from version to version of Node in the V8 C++ API. But unfortunately, one of the problems with NAN is that it's not really forward compatible. So you have something you have a compiled add-on that is running nicely on Node 10. You move to Node 12, you're going to have to recompile everything, and there's still a chance that NAN itself is going to need some work to catch up for Node 12. NAPI is kind of considered the new gold standard for how you should develop compiled add-ons. It provides API stability, so the API stays consistent across versions, but it also provides ABI stability, application binary interface, and this takes out the need for you to recompile your add-ons between versions. It's actually really cool. You can go from like Node Chakra Core to Node 4, Node 6, Node 8, and the same exact add-on will run everywhere. And then I kind of included the npm download statistics for this thing. It's got almost 1 million weekly downloads. That's kind of a bit of a lying number though, because this is a Google project, and Google actually includes all of these gRPC modules in all of their client SDKs and things like that. So the statistics get kind of a little false boost. Because originally when I saw the numbers for the gRPC downloads, it was greater than every other Node framework out there except for Express, obviously. But there are some problems with compiled add-ons. I personally don't like them. Computers don't like them either, apparently. So these are just within the past year a fraction of the number of issues that have been opened against the gRPC repository. Doesn't build on Windows, doesn't build with this version of Node, etc., etc. So the way to get around that is with gRPC and Pure JavaScript. And as I kind of alluded to, in my opinion anyway, compiled add-on should kind of be a last resort. You have some legacy code or something else or you absolutely need the most performance possible. But I also feel if you're really that into performance, that JavaScript might not be the language for you. So compiled add-ons also have their own issues with performance, because if it's a very chatty app where you go back and forth across the C++ and Java boundary a lot of times, that'll actually provide enough overhead that it can offset any performance boost that you're seeing. And then another issue is that it really complicates your deployment. So you either need a pre-build available, like I was talking about earlier, or you need to have your deployment environment have the C++ toolchain and everything so that you can build and install these things. And then finally, it also really makes it harder for JavaScript developers to debug it. A lot of JavaScript developers just aren't C++ programmers, and there's nothing wrong with that. But whenever things crash in production, you still have to debug the thing. There aren't really a lot of tools out there that give you, a mixed view of JavaScript and C++ at the same time. You can use post-mortem debugging tools like LLNode, but those tools themselves are actually pretty fragile. So in general, I try to avoid compiled add-ons if possible.
And so this led to the gRPC team creating the grpc-js module, and they also moved it into the @grpc npm scope. So it's currently listed as a beta, but just from what I've seen in the gRPC repo, Google teams are moving over to it, so it must be stable enough. It's API compatible with the gRPC module, so it doesn't have all of the features that the other one does, but it's a drop-in replacement, and if a feature is not supported, it'll throw an error and let you know about it. It's written in TypeScript. The people at Google seem to be big fans of TypeScript for whatever reason. And it uses Node's HTTP2 module under the hood, so it takes out the compilation step. Everything is already there with Node. HTTP2 became officially supported in September of 2018 with Node 10.10, so it's good to use now. And then there's actually a required Semver version that is checked every time you try to require the module, because you have to have this good version of HTTP2, so it'll throw if you're trying to use something that's not in that version. I recommend trying to run it with the latest Node 10 LTS if you're in production. Node 8 is still, it's a little more shaky on the HTTP2 implementation, and Node 12 hasn't entered LTS yet, so I would target Node 10. Currently, the only production dependency on this module is Semver, which is used just to enforce that range check. And so this is what an example Unary client is going to look like. Can everyone in the back see the code? Okay, cool. So you're going to require the grpc-js module. Because of space limitations on the slide, I left out the part where you're loading the protobuf into memory. I'll get to that in a couple slides. But you're going to define your echo service, where you want the client to talk, what kind of credentials you're going to use. So they have insecure credentials if you just want to talk over HTTP2 with no security. That's simpler for testing, but in production you're going to want to use secure credentials. Once you get your client, it's as simple as calling echo Unary. That, if you remember back to the example with the protocol buffer, that was what we called the Unary RPC. Remember, it takes one object that has a key name value, which is a string. So we're saying hello Unary. It's not async await friendly yet, so it still does the callback API, but it's just a normal Node.js callback, so error and response. You handle the response and then close the connection. So that's kind of the basic Unary call. Next is the client streaming call. It's nice because it just exposes Node Streams API. So if you know how to work with Node Streams, you know how to work with this. It's generally the same thing. So you're still setting it up the same way, creating your echo service, and then creating your stream here, which is going to handle the response from the server, because remember, there will only be one response from the server here. And then down at the bottom here is where we're actually using Node Streams API to kind of pass the same message. And then once the server processes it, you get the callback and everything else is the same. Next is the server streaming API. So the opposite of what I just showed. So in this case, you create your server stream, and then on the client, you basically set up handlers to work with the incoming stream. So it's going to be basically a Node.js readable stream. And then a Bidi stream is basically a combination of the last two. So you're going to set up your readable stream to handle the response coming back from the server, and then use the writable stream API to send messages to the server. And so before, I skipped over the part about how you load protocol buffers into memory. The original gRPC module has functionality built in for that, but once they moved over to grpc-js, they started using proto-buff.js as the way to kind of parse protocol buffers, and they wanted a way to kind of shield shield gRPC users from any types of API changes or things like that in proto-buff.js. So they built this as a wrapper, and then this little piece of code basically requires it for you. So you require grpc-js, require the proto-loader, and then there's a load and a load sync. So here we're using load sync just for simplicity. We're going to import example.proto. Keep case false. So that means keep case, basically whatever's in your protocol buffer is how the name will be in JavaScript. By setting it to false, it'll convert all those names into camel case for you, so it kind of follows more standard JavaScript naming conventions. And then there's just some other options, longs and enums set to string. That just means what kind of data type are you going to use in JavaScript to represent those data types in protocol buffers, because it's possible to get a long number that doesn't fit into a JavaScript number, because of just different bit sizes and things like that. So we can use a string to represent those. And then at the time, whenever we first started down this path, gRPC-js only implemented the client side of things. There was no server implementation. We needed a server implementation. We tried using the gRPC module. It worked, but when we were jumping around between node versions, things didn't work. It would segfault, and just it was a pain in the a pain. And so I created this server myself. It's not an official module. It lives under my GitHub account. But it's pure JavaScript, no TypeScript other than the types file that is alongside of it. The only production dependency is grpc-js, which I use for a shared metadata class. I thought it was easier to just reuse that than to rewrite it, and some shared status constants. The statuses are kind of like your HTTP status codes. gRPC has their own collection of those. And then as I was working through it, it actually led me to contributing a number of patches back to the upstream that helped as far as performance went. So this is what an example server is going to look like. This is still the same example as before. So here's our handler for the Unary call, for the client stream, the server stream, and the bidirectional streaming. So since we're just echoing back whatever comes in, the call is what's going to contain the data that's passed in from the client. So we're calling back with no error, and then whatever the request was. And then similarly, we set up the Node.js streams, kind of like we did with the client connections. Like I said, if you can use the Node Streams API, you're pretty much good to go with this. So one of the things that I kind of figured out about the gRPC team is they tend to leverage TypeScript and the static types more than tests, and that led to me finding some significant bugs. Just little things like compression not working at all, and authentication being broken, just little things. So I was able to add more tests. I got up to 95% test coverage. I mean, this all started a year ago, and as of like I think it was just last week, there was a new release of gRPC-js where they broke the client. For whatever reason, their testing didn't catch it. My test did. I reported a bug. They fixed the client. So it's good to have test coverage. And then some improvements that I made to the server. So their metadata class was kind of really inefficient at the way that it was handling headers. So it had, because it was a client, it had like specific headers that it was looking for and then explicitly calling delete on. Delete is not something you should really do a lot of in JavaScript. V8 under the hood doesn't like it. It changes kind of the hidden shape of the objects and can lead to slowdowns. So that was useful for the client, but then on the server side, it actually saved me an entire loop through all of the headers every time a request came in. So it was a pretty substantial savings there. Some code simplification. So instead of using objects as maps, we use actual maps as maps. Removed a lot of like unnecessary functional calls. So they had a lot of like .map, .for each, whatever chained together. Replace those with one loop. Simplification. Drop their dependency that they had at the time on Lodash. So Lodash, that's an extra dependency, extra security liability. But the Lodash implementations of these methods that they were using are also more complex than what they needed for gRPC. So just by dropping that and the other changes, I was able to get like a 15 to 20% improvement in requests per second on the server. And I presented this work back in March at gRPC Conf and was talking to one of the maintainers, and asked if it would be okay to try to upstream this work. And as of June of this year, that's officially been done. I will say, if I were looking just for a server, I would still use grpc-server-js. I'm not saying that just because I wrote it. I wrote both of them, but as I was porting it to TypeScript, there were actually instances where I was writing code and the TypeScript compiler didn't like it, and I ended up writing like what I know to be less good code just to appease the TypeScript compiler. And then I still have better testing and things like that. So, but if you want just one package that's officially maintained by the Google team, then gRPC-js is a good one for you. We did some benchmarking. So this was my implementation, the compiled add-on. Kind of what I expected here was the little bit of drop-off in performance, but huge drop-off in complexity. Golang obviously is fast. I was actually expecting higher numbers for Rust, but for whatever reason, that's just how things shook out. But yeah, so I mean, performance basically stayed on par with what they had before, so I was happy with that. Unfortunately, there are some pain points for working with gRPC because it's not as mainstream as just an HTTP1 REST server framework. In larger system architectures, you can bump into things like load balancers that don't understand how to speak gRPC. So, for example, I think they added gRPC support to Nginx and Envoy. I don't know that they're planning to add support to other servers. I know at least of one team who forked a popular open source server and added gRPC support for their own internal use. So that's something you need to consider. Also, benchmarking is kind of hard. So there are gRPC benchmarking tools, but it's really hard to get an apples-to-apples comparison of a gRPC server with something like Express or Happy or Fastify. And then kind of not from a technical standpoint, but trying to contribute to the project, it feels a lot more like a Google like internal project where they will accept patches, but you're kind of just getting in their way. So if you're looking for an open source project that you really want to contribute back to, this might not be the one for you. But if you're just looking for a framework to use, I can recommend it. And then it would also be nice to be able to support gRPC-web without Envoy. So it is possible. It's just nobody has taken the time to actually implement it yet. The protocol is published online. I've actually started doing some initial work on writing an in-process gRPC web proxy. So the goal of that would be, instead of having to introduce Envoy into your system, you could have a plugin for whatever your Node framework of choice is, be able to import this module and then be able to handle incoming gRPC web requests and proxy them up. So speaking of that, that's part of my plans for future work. Other things are more feature parity with the existing gRPC module. So they had a very large head start with that C core that they share between all the different implementations. So trying to get things like interceptors and other features that are missing. More work as far as performance and stability and things like that. I would like to experiment a little bit with node workers to see if a worker pool could actually improve performance a bit more. As I said, working on the gRPC web proxy, and then just kind of help for tools in the Node ecosystem. So it would be awesome if we could use something like AutoCannon to benchmark, across the different frameworks. And that's all I have. I don't know if Ellen DeGeneres is popular in Italy, but yeah, be kind to one another.